Hello, and today I will give some simple presentation about compressed vs incompressible flow.
So if we've got a compressible fluid, then what that means is we've probably got quite a lot of space between the molecules of that fluid. So if you think about a gas in a container, there's quite a lot of space between the molecules of that gas. So if we put a piston on top of that container and we try to push it down, what we could actually do is compress that fluid. So what that means is, for a compressible fluid, the density and the volume can change if you apply a force. An incompressible fluid is going to be one where there's no space or no usable space between the molecules. So this would be something like water, where the molecules of that water are very, very tightly packed together. So it doesn't matter how much we push down on the piston, we're not going to get any appreciable change in density or volume of the water inside that container, because there's nowhere for the water to go, because there's no space between the molecules. So if we put that into the context of flow, if we've got flow down a pipe that's compressible, so again we've got molecules with space in between them, then if we suddenly increase the pressure driving this flow, then we're going to get quite a complicated situation on our hands, because we're going to get an increase in velocity, but also probably going to be compressing the fluid, so that's going to make it very difficult to analyse. Whereas for an incompressible flow, so something where maybe we've got water in the pipe or something like that, then if the flow is incompressible, then it's much more straightforward to analyse, because there's no space for any compression in this system. What that means is, if we increase the velocity at this point in the pipe, we're going to get an instantaneous increase in the velocity at every other point in the pipe, because the flow is incompressible. It's basically, in this regard, acting like a solid. So it's almost like thinking about a train going down the pipe. If you push on one end, you're going to get an instantaneous increase in speed at all points in the pipe. So this also feeds into the idea that discharge for an instant in time has to be the same everywhere in this pipe with an incompressible fluid, because if we have 10 litres per second going into the pipe, we must have 10 litres per second coming out, because if it's incompressible fluid, then there's nowhere for the flow to go. So if we can't have 10 litres per second going in and 5 litres per second going out in an instant, because where has that other 5 litres per second gone? Or conversely, we can't have 5 litres per second going in and 10 litres per second coming out, because where has that other 5 litres per second come from? So incompressible flow is one where the volume and density can't change, and that means that when we've got something like a full pipe, we know that anything that we do upstream is going to instantaneously translate downstream.
Okay, there is a few examples. As we can see, the density of the incompressible flow is not changing compared to compressible flow.